Hello, this is Bala Krishnudu, lecturer in computer science. Today we will discuss the topic insertion sort. Insertion sort. Here insertion sort contains the two terminology. One is the sorting an unsorted list. This is a sorted list and unsorted list. So here now I will be taking one simple example like 42, 33, 28, 17. So please observe the index values. Actually in our C language, sorry, in C or Java or any language, array index value starting with the 0 to n minus 1. But for clearly understand purpose, now I am taking the index values like, for example, first value, this is the second value, this is the third value, and this is the fourth value. Means here index values, these are them. So total number of values is the n is equals to 4. So here I will be taking the total values are the 4. The values are the index values are the 1, 2, 3, 4. So here before sorting these values, we can divide our elements into two categories. One is the sorted list and second one is the unsorted list. Now I will be taking the values like 42, 33, 28, 17. So here I will be taking, this is the one list and this is the another list. Mean it is a unsorted list. This is the sorted list. It will be divided two categories, but the index are the same. That means this the index value is the 1, this index value is 2, this is index value is 3, and this index value is the 4. So just only I will divide, this is the sorted list and this is the unsorted list. Now we will take one more variable, temporary variable, that is temp is equals to, that means this is the first step. In step 1 I am taking the, in step 1 I will divide these two categories, sorted list and unsorted list. In step 1 we will take the first value will be stored in the temporary variable, that means temp is equals to 33. After that we are take that, means this variable will be stored into sorted list or moved to sorted list but appropriate location. This is a sorted list. Now we will to move this unsorted element value into the sorted list element. So for this one we will be checking whether 33, that means 33 is greater than, that means our 42, means if the 42 is greater than 33, if the 42, that means 42 means the sorted list value, if it is greater than 33, then this stored location, that means if you want here sorted list will be contains the two values, so that means we will take in the, so in this one the values are like this one, these are two values, this is the sorted list, this is the unsorted list, this means here this is a unsorted list. So here that is a sorted and it is a unsorted list. So in this one this is a 1, 2, 3, 4. So we don't think about the third element and fourth element, so that's why I put it like this one. But here if the temporary variable, that means it is now it is a blocked, 42 is greater than 33, that means sorted list value from right side, from right to left. What is the right value? There is only one value, so we don't need to know about the, we don't know exactly difference between the right to left onwards. So in next step we will be easy to identify why you are take the right to left to, because here we observe the only from the right to left in sorted list. Here there is only one element, so there is a, this is the left and this is the right value. right position value. That means it is a 42 is greater than 33. If it is a greater than 33, then we will be stored in this here. That means in the second value. That means we will be taken. That means here we will move the location. We will move the 42 into which position? Second position value. So that means we will be stored here 42. But here it is also confusion. That means it is also empty. If is there any more element? We are coming no element. So that's why we are put automatically 33. That means you must be checking if there is any element. Then after that, if there is any element, then once again we will check with the 33. If there is no element here, if there is no value here, so that's why automatically we will be stored in the 33 is here. That means now it is a sorted list value and this is the unsorted list value. So this is the step 1. In step 2, that means if you take one more step, that is the step 2. In step 2, same procedure. In this previous topic, same as it is. Now we will be taken how many values will be come to here. In step 1 we will get the 2. In step 2 intention means we will take the one more element in the unsorted value, that is 28, that will be arranged in sorted element list. So now we will take, that means it will be contains the, there are 3 values will be coming, 1 2 3. That means there is fourth one is the unsorted value. That means here we will be taken, that is nothing but this is the 17. Now we will be taken our temporary variable. That means temp is equals to, that means 28 will be stored in the temporary. So now in the previous topic, in the step I am telling that you must be comparing from right to left. So that means now we are comparing this right position value comparing with the 28. That means I will taken 42 is greater than 28. 42 is greater than 28. If it is true, what we will do? Just to move, if it is a true, move 42 into the third position. That means this is the first position, this is second position, this is the third position and fourth position. Now we will be 42 is greater than 2, then move the position, move 42 into third position. That means move means here inserting. That means in third position what will be contains, that is the 42. But our 28 must and should be comparing with the one more value is there. That means here there is one more value, must be compared to from right to left. So now 42 will be moved to the next location. Now what is the third 30? Now once again one more comparison, that is now comparing the 33 is greater than 28. If it is true, then move 33 to second position value. That means our third position of the second is, that is the 33. So what about this one? Is there any more element? There is no element value. So that's why simply our 28 will be assigned to first value. That means our 28 will be stored here. So this is the technique in the step 2. Then after that same procedure we will take in the step 3. This is here in step 2, this is the sorted, this is the unsorted value. Okay, now is there any one more value? There is an unsorted value. That means we will take in temp is equals to 17. Same procedure we will compare. That means 42 is greater than 70. 42 is greater than 17. Then move to fourth position. That means we will take in here, this is the 1 2 3. So move to 42 is here. Then after that once again, what is this? This is from right side to left side. After completion of the first right value and second right value, then 33 is greater than 17. Yes, it is a true. So that means move to third position. That means we are writing the, this is the 33. Then after that there is a 28 is greater than 17. Then we move to the second position and here 28 will be coming to here. Then there is there any more value? That means this is the first right second right and third. This is the last point. There is no value. That means our 17 will be inserting here. That is the here we are insert the values. So that means now it will be the sorted values. This it is the sorted values. This technique is called the simply insertion sort. First of all, what we can do, our insertion sort original data will be divided into two categories. One is the sorted list and second one is the unsorted list. Then after that we will be taking the comparison like this one, from right side onwards, from right to left. Take the 33 must and should be stored in the temporary. That means temporary variable you must be taken. Then after that here will be taken the temporary variable that must be stored in temporary variable. After that will be inserted in the position. That means this is the procedure to create the insertion sort. Now I will be write what is the algorithm for this one. That means now I am writing the algorithm for the insertion sort. Here same thing, we will take in the insertion sort array. Then after that we will take the number of values. Okay, so now we will write the algorithm like this one. So what is the first one? This is the first value. That means this is the n is equals to 4. Initially starting with the, is it starting with the 42 or 33? We are starting from the 33. That means this is the unsorted list. We will consider only unsorted list. For taking how many times? 1 2 3. That's why how many steps will be? 1 2 3. That means initially what is the step value? First value temp is equals to second position value. In second one, third next place temp is equals to third place value. Next one is the temp is equals to 17. That means fourth place value. That means our temp will be starting from the 2 to and ending with the n. So that's why we will be taken starting from, for I is equals to 2, I less than or is equals to n. Here means L less than L means 4. Then after that we are writing the I plus plus. So before starting all comparison, first what we will do, we are assigning 33 will be stored in the temporary variable. That means temp is equals to a of I. Then after that what can you do? You must be comparing from right side to right side. That means here this is the value. That means what we are right side value, this is the right side value. That means we are taken from the initially value is the 1. But what is the ending value? Here it is 1 and second one is that 1 2 and third place then it is the 1 2 3 and after that 1 2 3 4. That means here what is the starting value? 1. But we don't know, in step 1 there is only one value, but maximum is 1 or more than 1 2 3 1 2 1 2 3 like this one. So that will be considered like one. This is the first one. After that this is the second one. That means this is the 1 2 and after that it will be taken the 1 2 3. That means our comparison in internally comparison moving from right side to left one. In first situation it will be taken only one value. In first situation only 1 and second situation 1 2 and third situation 1 2 3 and fourth situation 1 2 3. But minimum position is the 1. So is it possible to more than 1? Yes, it is possible, but it is not less than 1 because of our index will be starting with the 1. That means our comparison will be starting with the 1 or more than 1. So that's why here I will be taken the one loop, that is while j is greater than or is equals to 1. J is greater than or is equals to 1. But what is the j here? So you will take what is the j? Starting value is the 1. That means before what we have taken before, here starting value is the temp is the right side value is the 1. If it is a 2, if it is a 1. If it is a 3, what is the right value? 2. If it is a 4, what is the right value? 3. That means it depends upon the step. If it is a I, what is the j value here? So that's why we will be taken the j is equals to I minus 1. What is the here j indication? From right side beginning. If it is a I 2, then it is a 1. If it is a 3, from right side to, that means if it is a 3 value, then j is the 2 to 1. If it is a j is equals to 4, I is equals to 4, then j is equals to from 3 to 1 is greater than or equals to 1. So that's why I am taking here j is equals to I minus 1 from right to left. And also, and you must be, when we are comparing, if it is greater than, then only, if it is greater than, then only moving. That means we will be taken a of j, a of j is greater than temp, is greater than temp. That means we are comparing, that is that 42 is greater than 32, then only we will move from less than. That means if it is a j plus 1 position will be moved. That means here if we have j is greater than temp, then what we will do, just we will be stored. That means the 42 will be, means here 42 will be storing in the second position. This is the first position value storing in the second position. If it is a j, the position value in the j plus 1. That means we are writing the a of j will be stored in a of j plus 1. That means first position value will be stored in the second position value. If it is j is equals to 1, that will be stored in the j of j, that means second position value. After that what we will do, our j value after comparison of 42, once again the value will be decremented by 1. That means 2, after comparison of 2, then we are going to the second value, that means the minus value. That means we are decrement j is equals to j minus 1, j is equals to j minus 1. So this process will be repeatedly until all values are comparison. After comparison of all values, what we are doing, and finally our temporary value will be stored in the first position value. That means we will be taken here a of j plus 1 is equals to temp. A of j plus 1 is equals to temp. That means after storing this one, temp is equals 28, that is the 42 33. Finally it will be stored in the 28. That means this value will be once again stored here. That means we are writing a of j plus 1 is equals to 10. That means this position value for this sorting the values, and finally this is indication for the inserting value, where our value, that means our temporary value will be located. This is the indication. So this is nothing but simply we are going to the algorithm. So this is the entire for loop, this is the outer loop. Now I am taking the while loop as inner loop. This is the decrement process, this is the increment process. That means this is the increment 2 3 4, this is increment process. That's why for this one we are taking the for loop. For this one, for right to left, for decrementing purpose, we will take the while. Why you are taking j greater than or equals to 1? Here the ending point is the 1. Why? What? When will we move the location? Just moving. Move the location means if it is a greater than temp value. That's why we are writing the j plus 1 is equals to j. That means this indication is just moving. From moving that. Then after that we can, after completion of the one value, move to the next one is next right value. That is the j is equals to j minus 1. After moving all values, finally our temporary value will be located. That value indication position is j value. So this is the algorithm for the insertion sort. And one more thing here also, there is, if you want the time complexity. So same process, how many moves are there? In step 1 there is a 1 comparison, in step 2 there is a comparison 2, in step 3 there is a 3 comparison. That means first step, second step and third step. Comparison means in first step there is a only 1 comparison, second step 2 comparison, third step 3 comparison. So here how can you recognize this one, the based on this one, how many there is a n is the 4, that means it becomes the 3 steps, 3 comparison. Like this one, there is a 1 plus 2 plus 3 plus up to plus n minus 1. This is the formula generation. Means there is a 4, n is equals to 4, then 1 plus 2 plus 3. There is a 6 comparison is enough. But if it is n is equals to, we don't know, maybe n is equals to thousands, then we can take the 1 plus 2 plus 3 plus up to n minus 1. Same formula for the sum of natural numbers, that is the formula is as equal n into n plus 1 divided by 2. But our n value, that means last value is the n minus 1, that means n minus 1 into n minus 1 plus 1 divided by 2. That means crossing, that means here n into n minus 1 divided by 2. That means our term complexity is big O of n square. This is the simple algorithm, and this is the way of explanation. And after that we are finding the time complexity for this insertion also. Plus please remember, in previous sorting techniques we are swapping the values, but here we are moving the value. There is no swapping in here. And one more point here, if there is all values if all values in the sorted values, for example, all values sorted values like this one, if I am take the all values like 17, 28, 33, 42. If we initially, if I am taking this one, that means initially means beginning values like this, already in sorted values, there is no need to comparison like this one. For example, if it is a 17 is the starting value, then after this 28 is comparison with the only 17, that means sorting value is the 17, 28. The next value is third value, third position means 28 is greater than 33, so there is only one comparison, 17, 28, 33. After that we are take the 42 is greater than 33, so there is only one comparison, that means 17 plus 28 plus 33, sorry, 17, 28, 33 after 42. So these are the only comparison, that means only one comparison, 1 plus 1 plus comparison. That's why if the already values are in sorting value, insertion sort take the time complexity, that is order of n. That means this is the best case, this is the worst case. At the time of worst case, the time complexity is order of n square. At the time of best case, the time complexity is the order of n. When it is occur, if all values are in sorting order, then if you want to insert the insertion order, then we will take in the order of n. But the previous sorting, that is bubble sort and selection sort, we are complete now. There is a worst case and best case, both are the order of n square. So this is the difference between the insertion sort, selection sort and bubble sort. So here there is a insertion sort, there is no swapping, there is no only moving from one where we are to insert the values. That's why the technique called insertion sort. Okay, thank you, thanks for watching my video. If you want more videos, please subscribe my channel. So we will discuss next sorting techniques in the next session. Thank you one and all.